Hello students, welcome to the lectures of Team Lesson Up. I am Zayed. This is our first video on IGCSE O-Level Physics. We are going to start off with the chapter Forces and Shape. For your convenience, we have decided that we'll divide this chapter into two parts. This is the first part. I hope you will find it useful. The things that we are going to talk about in this part are the definition of force. Then, the kinds of forces that we would normally come across while solving the papers or reading the books. And there will be also this third part where we'll be talking about the balanced and unbalanced condition of forces acting on a body. So, let's take a look at the definition of force. So, force is a push or pull on an object resulting from an interaction with another object. It is a vector quantity and thus it has a direction. In case you forgot what vector quantities are, well, the quantities that have both magnitude and direction are known as vector quantities. As I just said earlier, that force is a push or pull on an object resulting from an interaction with another object. So this interaction that we are talking about can be of two types. First one being action at a distance. So the kinds of forces that fall under this category are the gravitational force, electrical force, and magnetic force. I will talk about electric and magnetic force in my future lectures. So let's just look at the concept of weight now, which falls under the category of gravitational force. It is the force with which Earth pulls an object towards itself. So the object does not have to be in contact with the earth, in a physical contact with the earth. The force can have its effects from a distance. And it is calculated using the formula W is equals to m into g, where m is the mass and g is the acceleration due to gravity. And g has a value of 10 here, and m is the mass of the object, as I said earlier. Let's say you have a mass of 5 kilograms. Then think of your body as 5 individual bricks, each with a mass of 1 kilograms. In case of our planet Earth, it pulls each of those 1 kilogram bricks with a force of 10 Newton. 5 of these added together makes 50 Newton. That is what your weight is. If you were, let's say, a person with a mass of 80 kilograms, Earth would pull each of those kilograms with 10 Newton force, thus making your weight to be 800 Newton. Now let's talk about the forces in which an object has to be in contact with another object to feel the force. Normal reaction force is one of them. Then there is air resistance. Then there is friction, and then there is also this another force called upthrust. So the definition of normal reaction force says something like this: that the force exerted by a surface on an object to prevent it from passing through the surface. So let's say there's this car on the ground that we can see here, and let's say it has a weight of 100 Newton. We can also see that to counter the 100 Newton of force, two forces, each of 50 Newton, acts on the tires of the car that are the only parts of the car in contact with the ground. If this force opposite to the weight wasn't applied, the car would have passed through the surface and kept on going until it faced an equal force to its weight. And not only this, in this case we were looking at an example where there was a car on the ground. It could be you trying to pass through a wall. You are not able to pass through a wall because the force with which you hit the wall or hit that surface of the wall, you get hit back with the same amount of force. Thus you are not able to pass through the wall. Thus I'm stating it once again that the normal reaction force, it says that the force exerted by a surface on an object to prevent it from passing through the surface. So now let's talk about friction force. So when an object slides over a surface, the force that it feels opposite to its direction of motion is known as frictional force. This happens due to the roughness of the surface. With the naked eye, the surface of an object might look very smooth to you, but it isn't. The picture that you are looking at right now, the top surface in it could be your iPhone 6 and the bottom surface could be the floor. Now imagine your nephew sliding the phone across the floor. It is definitely supposed to feel a force that would be trying to stop it by acting in the opposite direction due to the roughness of the surface. So, and due to that force acting on that phone, at some point of time after it has been slided across the floor, it will come to a rest. So then there is also air resistance, and the definition is something like this, that the air resistance is the force that an object feels opposite to its direction of motion. Well, imagine you riding a motorcycle. The faster you ride, the more force you feel acting opposite to your direction of motion. This happens because the force with which you are hitting the air molecules with, they hit you back with the same amount of force but in the opposite direction to your motion. So thus we can say that the air resistance is directly proportional to the velocity of an object. The faster you ride, the more force you feel opposite to your direction of motion. The last force that we are going to talk about today is called upthrust. So it is a force felt by an object when it is submerged in fluid. So what is a fluid? Fluid is anything that can flow. It could be air, it could be any sort of liquid, or it could be even the sand in an hourglass. So when an object is submerged in a fluid, it displaces its own volume of that fluid to make it space in that fluid. So when that happens, there is this force that acts upwards on the object. It always acts upwards, by the way. Doesn't matter if the object is falling down or going up. So this force is known as upthrust. The last thing that we are going to talk about today is called balanced and unbalanced force conditions. So to understand this concept, what we need to understand first is what is resultant force. Well, the resultant force is that the final result after adding all the forces in a specific plane. So let's look at unbalanced forces. So unbalanced force condition applies when the sum of all the forces acting on a specific plane is not equal to 0. Let's look at this car. There is this force of 50 Newton acting towards the right of this car exerted by the engine, and then there is frictional force of 6 Newton acting on the car towards the left trying to oppose the motion, and there is also 5 Newton force of air resistance trying to oppose the motion once again. But the force of 50 Newton acting towards the right is greater than the sum of forces acting towards the left, which is 5 plus 6 equal to 11 Newton. Thus, there is a resultant force of 4 Newton acting here towards the right. What happens when there is an unbalanced condition like this? So, according to Newton's second law of motion, when there is a resultant force, as in our case it's towards the right of 4 Newton, there will be an acceleration of the object. Now let's look into the condition of balanced forces. So let's look at this car once again. There is this force of 50 Newton exerted by the engine of the car towards the right, and maybe you are holding it towards the left, exerting a force on the car towards the left of 50 Newton. Here the two forces are equal, so there is no resultant force. Thus, again according to Newton's second law of motion, when there is no resultant force, there will be no increase in the velocity of the object. That means there will be no acceleration. If the car is at rest, at that point of time, it will stay at rest. If it was moving at, let's say, 10 meters per second, it would keep on moving at 10 meters per second, and there will be no acceleration. That was all for today's lecture, Forces and Shape, Part 1. I hoped it was very useful, and Part 2 would be coming up very soon. If you have any suggestions, leave in the comment box. Thank you.